Hello class, we are going to look at practice 6.3, the first few problems here, and then you can finish the rest for homework. The first few problems talk about what is sufficient to prove that it is a parallelogram. So I'm going to look at this. Sorry, there. If we can look at these theorems, here are the four major theorems from section 6.3. These tell us what it can be to be a parallelogram. So you'll notice that each statement ends with then it's a parallelogram. So if we can satisfy the hypothesis, then we will have the condition. All right. If P is true, then it must be that Q is true. And that's on each one. Then it's a parallelogram. Then it's a parallelogram, and so on. So each one of these is showing us what is sufficient to prove it's a parallelogram. So, sufficient, there's that word. Is this statement sufficient to prove that it's a parallelogram? Okay, SPT, so this big angle, being congruent to SMT. Okay, is that sufficient? Is there a theorem that says if opposite angles are congruent? Okay, here it says if both pairs of opposite angles are congruent, then it's a parallelogram. Now, then the question is it sufficient to say that just one pair of angles gives me a parallelogram? What I'm going to do is I'm going to come up with a counterexample. Okay? If I had a kite, and draw a better kite than that. If I had a kite, okay, I would have opposite angles congruent, much like is stated here. But this is a counterexample because this is not a parallelogram. So that shows me one pair of congruent opposite angles is not sufficient to prove it's a parallelogram. So, state whether it's sufficient? No. Okay, that's the idea. I can go on to the next one. SPX is congruent to TMX. And TPX is congruent to SMX. All right, is that enough to prove that they're congruent? Here I'm talking about the diagonals, but the diagonals need to bisect each other, so I don't see a theorem here. So I just need to think, what is necessary to prove a parallelogram is to prove that these sides are parallel. When I have this case, I have alternate interior angles. Okay, so these two SMX and TPX prove this side. All right, and these angles right here, SPX and TMX, they prove that these sides are parallel. So even though there's not a theorem associated with it, I know by alternate interior angles that this is true. So I'll say yes, and I might even say because this is alternate interior angles. And I might even say here my counterexample, just to be clear. Okay, so I can make a kite for number one. And number two, I know alternate interior angle theorem. Okay, so then if I looked at number three, looking at number three, I have SM and PT. So a new situation, SM is congruent to PT, SP is congruent to MP. I know right away that that's a yes. And if I wanted to give a reason for that, I'd go up and say, which theorem is the one that says pairs of opposite sides? Then it's a parallelogram. So I can say yes, and that was theorem 6.5. Okay, so good luck. Don't feel like you always need to give a reason, but if you can give a reason, you're showing a little bit more understanding. So continue 1 through 6, finish the rest of the worksheet for homework, and you'll be ready for one more lesson tomorrow, and that'll be Friday. So I will see you all soon, and see you tomorrow in another video. Bye-bye.